All right, so today we're going to look at derivatives in multiple dimensions. So let f(r) take r squared to r and be defined by this piecewise function, where f of xy equals x to the 4 plus y squared if they're both rational and 0 otherwise. So let's first prove that f is continuous only at 0, 0. Okay, well, the 0, 0 case is pretty easy, so we just have to calculate this. In the case that xy is rational, we have it's equal to limit as x comma y goes to 0, 0, x to the 4 plus y squared is equal to 0. In the case that xy is not in the rationals, then we have this otherwise case, and then we get that's equal to 0. Both of these are equal to f of 0, 0. So it's continuous at 0, 0. Well, what about when it's not at 0, 0? When it's not at 0, 0, we can see that, taking the delta epsilon definition limits, I want to find, does this necessarily imply that f of x comma y minus f of x comma y prime is less than epsilon for arbitrary epsilon? And we see that this is not true. So say this is in the rationals, then by the density of the irrationals in the reals, we can always find an xy delta close to x prime comma y prime such that this is not in the rationals. And in that case, that would equal to 0, and this would equal to x prime to the 4 plus y prime squared. And that's not going to be less than epsilon for any epsilon less than x prime to the 4 plus y prime squared. Similarly, if it's in the irrationals, by the density of the rationals in the reals, we can find an xy delta close to x prime comma y prime, and in that case, this would equal x to the 4 plus y squared. That would equal 0, and again, by the same reasoning, we have that for epsilon less than x to the 4 plus y squared. This will not work. So it's only continuous at the origin, this function. All right, now let's find the partials. So using the formula for partial derivatives, d1f of 0, 0 is equal to, oh, by the way, this should be find the partials at the origin. So this would be equal to limit as t goes to 0 of f of t, 0 minus f of 0, 0 over t. That goes to 0, so we're really just trying to find the limit as t goes to 0 of f of t, 0 over t. And by the squeeze theorem, we can see that we're going to have 0 is less than, so in the case that t is irrational, it's bounded below by 0, and it's bounded above by t to the 4, which is always positive. Or I guess t to the 4 over t. I guess, well, let's take the absolute value of everything just to make things easier. Okay, so that's equal to absolute value of t cubed. And finally, taking limit as t goes to 0 of all sides, we see that limit as t goes to 0 of t, 0 over t is equal to 0, which implies that this is equal to 0. Similarly, for d, for the partial derivative with respect to y, we see it's equal to limit as t goes to 0 of f of 0, t of 0, 0, t goes to 0, limit as t goes to 0 of 0, t over t. Again, using the squeeze theorem, see that f of 0, t is going to be bounded above by, this time it's t squared over t. It's equal to t. All right, so taking limit as t goes to 0 of all sides, we get that limit as t goes to 0 of f of 0t over t is equal to 0, which implies that this is equal to 0. So our partials are just in, so that's going to be actually our candidate for df00, since these are each the partials. So in order to prove that's actually differentiable, we want to show that our total derivative limit is going to equal to 0. In other words, we want limit as x comma y goes to 0, 0 of f of x comma y minus f of 0 comma 0 minus, and this remember was our candidate from calculating the partials, x minus 0, x minus 0, 0 over y minus 0, normal of that, over x comma y minus 0, 0, show this equal to 0. All right, so these both go to 0. So now all we just want to show, and again, in taking the norm of this, that's just the norm of a vector. This is a scalar valued function, so taking the norm of that is basically like taking the absolute value. So what we want to do is show that limit as x goes to y goes to 0, 0 of f of xy over square root x squared plus y squared equals 0. Is that true? Okay, so we're going to use this squeeze theorem again. So it's bounded below by 0 because both of these quantities are positive, and when x comma y is irrational, this quantity will go to 0. So, as for the bound of above, that's a bit trickier, but we're going to use polar coordinates for this. And how are we going to use polar coordinates? Well, notice that we can write x equals r cosine theta, y equals r sine theta. For r in 0, comma 1, actually r in positive reals, let's do this. And then for theta in 0, comma 2 pi. Yeah, okay, so we can express any x and any y as this. So basically, now what we want to do is, maybe I'll do a union 0. Okay, so now what we want to do is we want to express this x to the 4 plus y squared in terms of polar coordinates. So just write it here on the side. It's going to be equal to, and that's just going to be r to the 4 cosine to the 4 theta plus r squared sine squared theta over, and this is just going to be absolute value r. And that's pretty simple. We can just cancel the r from both sides to get that. That's equal to r cubed cosine 4 theta plus r sine squared theta. And that's going to be our bound. Okay, now taking limit as x comma y goes to 0 is just going to be the same as taking the limit as r goes to 0 from the right. Make sure you see why this is true. And then we get, by squeeze theorem, that this is equal to 0. In other words, f is differentiable at 0, 0, and df00 is going to be our candidate. That's all.